exponents. So for exponents, we have a variable. Sometimes you don't always, you could have the number 2 to the third. That has no variable in it, but it has my base here. In this one, my variable is the base. I have an exponent or a power. And I could even have a coefficient. In this one, when I have the 6 is not being, like this 5 does not apply to the 6. It only is applying to the x. So my coefficient is just like, you do x to the 5th first, because remember our PEMDAS exponent comes first, and then we would multiply it by the 6. Let's look at what these look like. So an exponent means how many times the variable, the base, whichever thing it is multiplied with itself. So that x to the 5th we had back there means it's x times x times x times x times x 5 times. So 3 to the 4th is just going to be 3 multiplied with itself 4 times. 1, 2, 3, 4. If you want to know what that actually is, we just, multiply it. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 2 to the 3rd, we're going to multiply 2 with itself 3 times. Oop, no 3's. 2 times 2 times 2. I have 3 of them, right? And if I want to know what it is, I multiply them. 2 times 2 is 4. 4 times 2 is 8. Now, the 0 power. This is a tricksy little one. The 0 power means there are none of them. There are no 5s. So you have nothing. However, powers are always multiplying. So we need the multiplying version of nothing. The adding version of nothing is 0, because if you add 0 to something, it does not change the number, right? 11 plus 0 is still 11. Multiplying, though, 0 does not work like that, because 5 times 0 is 0. It did change it, right? So we need to think of what, when you multiply it, does nothing. And the multiplying version of nothing is 1. So we have no 5s at all. We have the multiplying version of nothing. And the multiplying version of nothing is 1. Anything at all to the 0 power is always 1. They could put so many things in there. They could be like 17 plus 3x squared plus 4y minus 2. And when they put it to the 0 power, forget it. The whole thing's equal to 1. It doesn't matter. Those are the basics of exponents. What happens, though, when you get into negatives? When you have a negative base, your exponents, it works the same. You just have to be careful, right? It's still 2 negative 3's. So it's negative 3 times negative 3. And a negative times a negative is a positive. So negative 3 times negative 3 is positive 9. Now, negative 3 to the 3rd power. I have 3 of them now. We're going to simplify it like we did before. This guy turns into 9. And now we have a positive times a negative. So this turns into negative 27. Let's keep going. Negative 3 to the 4th power means I have 4 negative 3's. This guy turns into 9. This guy turns into negative 27. And now we have a negative times a negative. It goes back to being a positive. So in general, a negative to an even exponent is going to have a positive answer. And a negative base to an odd exponent is going to have a negative answer. You can also always put these in your calculator, though, truly.